In this video, we'll turn our attention to how addressing and forwarding are done in the internet. Internet addressing and forwarding are important components of the internet protocol, that is IP. There are two versions of IP in use today. They are IPv4 and IPv6. We will first examine the widely deployed IP protocol version 4, which is usually referred to as simply as IPv4. We'll see IP version 6, which has been proposed to replace IPv4 at the end of this video. Now we'll see the IPv4 datagram format. Recall that a network layer packet is referred to as a datagram. We begin our study of IP with an overview of the syntax and semantics of IPv4 datagram. IPv4 datagram is shown in this figure. The key fields in the IPv4 datagram are following: version number, header length, type of service, datagram length, identifier, flags, fragmentation offset, time to live, protocol, header checksum, source and destination IP addresses, options, and data or payload. Version number: these 4 bits specifies the IP protocol version of the datagram. In this case, it is the value 4, that is, this field containing the value 0100 indicates version 4. Next, header length. IPv4 datagram can contain a variable number of options which are included in the IPv4 datagram header. These 4 bits are needed to determine where in the IP datagram the data actually begins. The typical IP datagram has a 20-byte header. Next is a type of service. The type of service bits were included in the IPv4 header to allow different type of IP datagrams. For example, datagrams particularly requiring a low delay, high throughput, or reliability to be distinguished from each other. For example, it might be useful to distinguish real-time datagrams such as those which are used by an IP telephony applications or from non-real-time traffic, for example FTP. So this field of IPv4 header to allow different type of IP datagrams. Next is datagram length. This is the total length of IP datagram, header plus data, which is measured in bytes. Since this field is 16 bits long, the maximum size of the IP datagram is 65,535 bytes. Next, identifier, flags, fragmentation offset. These 3 fields have to do with the so-called IP fragmentation. The new version of IP, that is IPv6, does not allow for fragmentation at routers. Next is the time to live. The time to live field is included to ensure that datagrams do not circulate forever in the network. This field is decremented by 1 each time the datagram is processed by a router. If the TTL field reaches 0, the datagram must be dropped. It indicates how much time the datagram should reside in the network. Next is protocol. This field is used only when an IP datagram reaches its final destination. The value of this field indicates the specific transport layer protocol to which the data portion of this IP datagram should be passed. For example, a value of 6 indicates that the data portion of the is passed to TCP, transmission control protocol, while a value of 17 indicates that the data is passed to the UDP, that is user datagram protocol. Next is header checksum. The header checksum leads a router in detecting bit errors in a received IP datagram. Next is the source and destination IP addresses. When a source creates a datagram, it inserts its IP address into the source IP address field and inserts the address of the destination into the destination IP address. Next field, options. The options field allow an IP header to be extended Header options were meant to be used rarely, hence the decision to save overhead by not including the information in options field in every datagram header. And the last one, that is the field is data or payload. The data field of the IP datagram contains the transport layer segments, that is TCP or UDP, to be delivered to the destination. Now coming to the IPv6 datagram format. The format of the IPv6 datagram is shown in this figure. The following fields are defined in the IPv6 version. So first one is the version, second the traffic class, flow label, payload length, next header, hop limit, source and destination addresses, and data. Now coming to the description of each fields, the first field, that is version. This 4-bit field identifies the IP version number. Next is the traffic class. This 8-bit field is similar to the type of service field we saw in the IPv4. Next is flow label. This 20-bit field is used to identify a flow of datagrams. Payload length. This 16-bit value is treated as an unsigned integer giving the number of bytes in the IPv6 datagram following the fixed length, that is 40-byte datagram header. Next is the next header. This field identifies the protocol to which the contents of this datagram will be delivered. For example, to TCP or UDP. The field uses the same values as the protocol field in the IPv4 header. Next is hop limit. The contents of this field are decremented by 1 by each router that forwards the datagram. If the hop limit count reaches 0, the datagram is discarded. Next is the source and destination addresses. So this field indicates the source and destination address. And the last field, that is data. So this is the payload portion of the IPv6 datagram. When the datagram reaches its destination, the payload will be removed from the IP datagram and passed on to the protocol specified in the next header field. So this is all about the IPv4 and IPv6 versions of Internet Protocol. Thank you for watching this video.